Deep sea fish. Evolution. Deep down in the ocean, there is no sun. There is no light. There is just cold, dark water, forever. You would think nothing can live there. But something does. Strange fish. Very strange fish. Scientists used to think the deep sea was empty for a very long time. They thought fish could not live there until something changed the food supply way back in time, in the late Jurassic period. Plants on land started to flower. More flowers meant more food falling into the ocean. More food meant more little creatures could live on the sea floor. And more little creatures meant fish finally had a reason to move in. But here is a twist. Some deep-sea fish today come from very old family lines, older than flowers. So maybe fish moved into the deep sea earlier than we thought. We just don't have the fossils to prove it. Yet. And speaking of fossils, the oldest proof we have is strange. It's not even a fish. It's a trace, a footprint, but for swimming. Scientists found 130-million-year-old marks in rock in Italy, marks made by a fish swimming and feeding on the ancient sea floor. The fish is gone, but its move is still there, frozen in stone. Later we get real fossils. Environment. Let's talk about the ocean like a building. A very tall building with floors. The top floor gets all the sunlight. This is the epipelagic zone. Plants grow here. Fish are easy to see here. It's nice up here. But this top floor is thin. Only about 200 meters deep. Below that, there are hundreds and hundreds of meters with no light at all. In fact, about 90% of the whole ocean is completely dark. Go down further, and you enter the mesopelagic zone. Some call it the twilight zone. A little bit of light gets in, but not much. Go down more, past 1,000 meters, and there is no light left at all. This is the bathypelagic zone, and if you keep going past 4,000 meters, you reach the abyssopelagic zone, the basement of the ocean. Down here it is cold, usually around 1 to 4 degrees Celsius, and the pressure is huge. For every 10 meters you go down, the pressure grows by 1 more atmosphere. At the bottom of the bathypelagic zone, the pressure is about 400 times what you feel on land. So how do fish eat down here with no sunlight and no plants? They eat leftovers. Dead plankton, dead skin, and waste slowly fall down from above, like snow. Scientists really do call it marine snow. But most of this snow gets eaten before it even reaches the deep water, so very little food actually makes it to the bottom. Characteristics. Deep-sea fish look like nightmares, but every strange feature has a job. Many are completely blind, no point having eyes in total darkness. Instead, they feel changes in water pressure. And they smell very well. It's like they read the ocean with their skin. Other fish go the opposite way. They have huge eyes, much more sensitive than ours, built to catch tiny bits of light. One fish, the silver spiny fin, has 38 copies of the gene that helps eyes see in dim light. Most animals only have 1 copy. This fish went a little overboard, in a good way. And then there is glowing. More than half of deep-sea fish can make their own light. This is called bioluminescence. They use it to find food, to scare enemies, and to find a mate in the pitch black. Some fish even glow on their belly to match the light from above, so predators below can't see their shadow. It's like a magic invisibility cloak made of light. Deep-sea fish don't have swim bladders like normal fish. A swim bladder is a gas bag that helps fish float. But gas gets crushed under deep-sea pressure, so instead many deep-sea fish have jelly-like bodies, weak bones, and lots of fat. This makes them lighter than water without needing gas at all. It also makes them slow, very slow. They are built for waiting, not chasing. Adaptation to high pressure. Here is a fun fact. If you take a deep-sea fish and bring it to the surface, it can explode, not because it's angry, because gas inside its body expands as the pressure drops. So please don't try to keep one as a pet. But how do these fish survive such pressure in the first place? The secret is inside their cells. High pressure squeezes cell walls tight, like a plastic bag being crushed. This makes it hard for the cell to do its job. So deep-sea fish changed the fat in their cell walls, using a kind that stays soft even under pressure. Their walls stay flexible, like a rubber band instead of dry plastic. Their proteins are different too. Normal proteins can break down under pressure. Deep-sea fish proteins are built stronger, with tighter bonds, so they can survive the crush. This also makes them handle heat very well. Strange, right? Fish built for freezing cold, but tough enough for heat too. Even their body chemistry changed. Chemical reactions that need more space are blocked by pressure. So deep-sea fish evolved reactions that need less space. Life finds a way, even 4,000 meters under the sea. Lanternfish. If deep-sea fish had a king, it would be the lanternfish. Small, simple, and absolutely everywhere. Lanternfish make up as much as 65% of all deep-sea fish. That is not a typo. Almost 2 out of every 3 deep-sea fish you find is a lanternfish. Their total weight in the ocean is around 550 to 660 million tons. That's several times heavier than everything humans catch from the sea in a year, combined. These little fish live in the twilight zone, and at night they swim up to the surface to eat, then go back down during the day to hide from bigger predators. Millions of them move up and down every single day. During World War II, sonar operators on ships kept detecting something strange, a fake ocean floor deep underwater that seemed to move up and down depending on the time of day. It wasn't the floor. It was millions of lanternfish and other small fish, all moving together. Scientists now call this the deep scattering layer, a whole hidden layer of ocean life, thick enough to fool a submarine sonar. Lanternfish are small, but they are the reason so many bigger animals survive, from squid to penguins. Take away the lanternfish, and a huge part of the ocean's food chain falls apart. Endangered species. Not every story about the deep sea is bizarre and fun. Some of it is sad. For a long time, humans mostly fished near the coast in shallow water. But shallow fish started running out. So fishing boats went deeper, down the slopes of the continental shelf, as deep as 1,600 meters. And that is a problem, because deep-sea fish don't reproduce fast. Some of them reach adulthood at about the same age as a human. Slowly, carefully, which means once you overfish them, they cannot bounce back quickly. A study by Canadian scientists found that several deep-sea fish, including the blue hake and a type of spiny eel, are now close to extinction, not because they were hunted directly, but because fishing boats moved into their home looking for something else and caught them along the way. It's a strange kind of tragedy. These fish survived crushing pressure, total darkness, and near-freezing cold for millions of years. And the biggest threat they've ever faced showed up in the last few decades, in the form of a net.